In our very first section, we're going to go through 1.1, which is about linear equations in a single variable. So we have three main things we're going to cover. The very first thing is, what does a linear equation look like? How do we go about solving linear equations? And then finally, are there special classifications or types of linear equations once we find out how many solutions there are? So first and foremost, we have to talk about, what does a linear equation look like? So we're going to be focusing on a single variable here. Typically it's going to be x, but sometimes it could be y, it could be p. If it's based on a real problem, it might represent the variable of that specific thing. Like if you're talking about a volume, you might use v. But essentially you're going to have some constants, a and b. They could be rearranged. You could have multiple x's on one side, multiple constants on another side, but any equation will boil down to this form: ax plus b equals 0. So just to give you some examples, you're going to have a number times x plus a number equals 0. That's one example of a linear equation. Here's an example where it's rearranged, and then the other two give you examples of different variables. And again, it can be whatever variable pertains to the problem you're dealing with. So really our main goal when we're solving these is we just need to isolate the variable. We want to use operations to get x equals a single number. Might be a fraction, might be a nice number, it depends. So let's just get a ton of practice solving. We want to first work with solving the equation 2x plus 4 equals 0. So the thing you want to remember is that no matter what you do to one side, you have to do to the other. So we want to get this 2x on its own, but currently we have this plus 4 with it. So I need to bring that plus 4 to the other side. And addition is undone by subtraction. So if I'm adding 4, I'm going to subtract 4 to cancel it out. But what we do to one side, we have to do to the other. And then we'll go ahead and simplify the equation from here. So the 4's end up canceling each other out. That leaves us with 2x on the left and negative 4 on the right. Now here, I still don't have x by itself, so I need to get rid of that 2 out front. And currently it's 2 times x, so what undoes multiplication is division. So we go ahead and divide both sides by 2. And so again, the 2's will cancel, and that leaves us with a single x on this side. On the right-hand side, negative 4 divided by 2 gives us negative 2. So ultimately, we end up with a single value for x, and that's our goal. That's what we want to solve. So if you have time, if you're ever unsure, especially in a testing situation, if you want to make sure you did the problem right, you can always check your answer by plugging it into the original equation. So I'm not going to do that for every problem, but at least show you on one how to do that. So we want this to be a solution, so we plug it back here up at the start. So we need 2x plus 4 to equal 0. If our x is equal to negative 2, that will give us 2 times negative 2 plus 4 equals 0, which is negative 4 plus 4 equals 0. And indeed, we end up with something that is a true statement. So this is our correct solution. Let's try a more complicated one. We've got 2x plus 4 minus x equals 4x minus 5. So unfortunately, I have quite a few x's on one side, and then we also have constants on both sides of the equation. So there are going to be multiple ways you can do any of these problems. I'm only going to be showing you one way, but stick with what your gut tells you. So my instincts say, because we have got these x's on both sides, let's go ahead and combine these like terms. So we want to count how many x's we have in total. So we have 2x and then minus x. That gives us a single x on this side. And then the rest of the equation we keep exactly as is. And from here, now we go through and solve as we did before. We still have x's on both sides of the equation, so I want to bring all x's to one side. And in this case, you could bring the 4x over, but the problem in doing so is you end up with negative x's over here. So instead, what I'd prefer to do is subtract the x from each side. And this way, I end up with a positive number of x's. But again, the other way works as well. So that leaves us with 4 on the left-hand side. Now we have 4x minus x. That gives us 3x. And then we still have the minus 5. Now here, we want to get x by itself, which we've gotten it to one side, so that's good. But we still need to get rid of this minus 5. So to undo the subtraction, we go ahead and add 5 to both sides. And by doing that, our 5's cancel each other out. 4 plus 5 gives us 9. And we're left with 3x over here. And now, just like our last example, we've got 3 times x. We go ahead and divide by 3 to make these cancel each other out. And 9 divided by 3 gives us 3. And that is equal to x. So that is our solution for the equation. So again, I could plug that back into our starting equation up here, but for time's sake, I'm going to avoid doing that. All right, let's try our next example. We'll make it a little bit more complicated. So here we've got our variable on both sides of the equation again, but we also have this operation where we have negative 4 times some stuff in parentheses. So the very first thing we need to do is we need to distribute this negative 4 to both pieces. So this way it wipes those parentheses and gives me something a little bit simpler to work with. So we've done absolutely nothing. So we've done absolutely nothing on the left-hand side, so we leave that as is. Now on the right-hand side, we're going to get negative 4 times y, and then we get negative 4 times positive 1. So to simplify that, we get negative 4y minus 4. So you're more than welcome to just jump from this step down here, but if you need that extra step in between, you're just taking the negative 4 timesing by both pieces. And now from here, we're exactly where we were last time. We want to isolate this y variable. So I don't like this minus sign, so I'm going to go ahead and add 4y and do exactly the same thing over here. So the 4y's cancel each other out on the right-hand side, and over here, we've got 2y plus 4y, so we have 6y. We've still got this plus 6, and we still have the minus 4 on the right. Now we need to get rid of the plus 6, so we go ahead and subtract it to undo the addition. Those two cancel each other out. We're left with 6y on the left and negative 10 on the right-hand side. And so one final step, we've got 6 times y, so we divide by 6, but we've got to do exactly the same thing on this side. So that leaves us with y is equal to negative 10 over 6. Problem with this, it is not simplified. If it tells you to leave your answer in exact form, you definitely don't want to plug this into your calculator because you're going to get a decimal that goes on forever. So what we can do, both the top and bottom are divisible by 2. So we're going to divide both of them by that. That leaves us with negative 5 in the numerator and 3 in the denominator. So ultimately, we end up with y is equal to negative 5 over 3 as our simplified solution. If it doesn't say you have to simplify it, then absolutely you could leave it in that original form. But typically we want it as simple as possible. Okay, so let's take it up an even bigger notch. Now we're going to work with some fractions. And unfortunately, fractions make things way more complicated. So almost all of the time when we're dealing with an equation, my advice to you is always to clear your fractions. Not going to be the case in some instances, but typically wipe your fractions. So what I want to do is I want to get rid of this 3, 6, and 6 in the denominator. So if I take each of these fractions and multiply it by 6, it's going to wipe them. So you're basically looking for a number that's divisible by 3 and divisible by 6 as well. If I took this equation and multiplied it by 12, that would work too, but it just is more than what we need. So the simplest number we can do is we're going to take everything and times it by 6 to wipe these fractions. So if we do that, we'll have 4x plus 1 over 3, and we're going to times it by 6. We'll have 6 times the fraction, x plus 5 over 6, and 6 times x minus 3 over 6. Now on the right-hand side, we're lucky in that those 6 over 6 just cancels. But unfortunately over here, when I take 6 and divide it by 3, we're really left with a 2. So I need to take 2 and I need to multiply it by the entire numerator. And then on the right-hand side, we're just going to have the one numerator plus the other. And from here, now we just solve it as we did before. I want to get rid of all these parentheses, so we need to distribute the 2 to both pieces. Over here, I don't need the parentheses. I just made it that way, so in case you had something that was left over when you simplified, you could continue in that form. And we're going to get 2 times 4x, which gives us 8x, and then 2 times 1 gives us 2. On the right-hand side, we have the x plus 5 plus x minus 3. So grouping our like terms, we have x plus x. So we've got 2x there. And then we have 5 minus 3. That gives us a plus 2. Now we want to isolate our variable. So let's go ahead and bring the 2x to the other side by subtraction. This way they cancel each other out. That leaves us with 6x plus 2 equals 2. Got to isolate the x again, so let's bring the 2 over. Those cancel each other out, and that gives us 6x. But on the right-hand side, those also cancel each other out. So it ends up giving us 0. So we still keep going from here. We can divide by 6 to get x on its own. And that finally leaves us with x equaling 0. That is our solution. And again, you could plug it back in to check that it works out. So the very last thing we're going to go through is we're going to talk about special types of linear equations. Pretty much everything we've done right now has had a single solution. So every example so far has been what's known as a conditional equation, a single solution. But if you end up with something that doesn't make sense in the end, so there's no number that satisfies it, that's when we have a contradiction. So the statement contradicts itself. In the case that no matter what you plug in, you get a true statement, that's where we have an identity. So we've already seen tons of examples of conditional equations. Let's go ahead and go through the other two types. So we want to solve this equation and we want to identify the type that it is. So I need to isolate my x variable, which means I've got to get rid of these parentheses. So we're going to go ahead and distribute the 5. On the left-hand side, we still have the same thing. On the right-hand side, we have 5 times x, and then 5 times negative 4. So once we distribute that, we're ending up with 5x minus 20. So I want to isolate my x variable again. So let's bring our x's to one side. But in doing so, it ends up canceling out both of them. And the statement that we're left with is negative 15 equals negative 20. And this in no way, shape, or form is a true statement. And because of that, there's no solution. No matter what you plug in, you're going to end up with something that is false. So this is the type where we have a contradiction. Okay. So anytime you end up with something that is a false statement, so it does not work, you have no solution, in turn, a contradiction. In our last example, instead of ending up with something that's always false, we're going to get something that's an always true statement. So we're going to look at almost an identical example, but we're changing this to a -3. So we still want to distribute the 5 to both pieces. That gives us 5x minus 15. We get 5 times x, and then 5 times -3 is -15. So if I go ahead and subtract the 5x from both sides, same thing happens again. The 5x's cancel, but now the statement we're left with is -15 equals -15. So this is always true. No matter what you plug in, you have a true statement. So there's really an infinite number of solutions. All real numbers work. So because it is always true, this is an identity.